All right, so today we're going to talk about how to go from the reduced echelon form of a matrix to the null space of the matrix. So let's say that you have a matrix A and it has a reduced echelon form. And now you want to find the null space of that matrix. Let's say that your reduced echelon form, let's say, is of the form 1, 0, 0, 0. Let's do one more row. And let's say now that we're going to put a non-pivot position. By the way, the leading one in each row is going to be called a pivot position. So that right there is a pivot. All right. Let's say that that is your pivot position. Now, let's say the next one, the next column is going to represent a free variable. So not a pivot position. So let's say you have a 2, 0, 0, 0, 0. So why do I say it's a free variable? Is because it does not correspond to a pivot position. You see there, it doesn't have a 1 that starts a row. So that means that's a free variable. So the variable x2 is actually going to be a free variable for the system of equations. And since you're setting your system of equations ax equals 0 to find your null space, remember the null space is the space of matrices that for which a times x, the space of vectors such that a times x is going to be equal to 0. So let's write another pivot position, another pivot column. So let's say 0, 1, 0, 0, 0. All right, so pivot because, well, this is the leading one in the row. So that column is going to be what we will say it's a pivot position. All right, so now let's do two columns that are not pivots. So let's say you have a 3 and a 1, and then no leading ones there in the row. And then let's do another one. So let's say you have a -2 and 1. Maybe let's change that to a 4, just because I want to illustrate, and I don't want ones there. There's nothing wrong with the ones, I just want to illustrate how it works. So I want to put every number without a 1, because the ones will play a specific role, that's why. All right, so how would you do normally to get your null space? Well, you would write your systems of equations. By the way, my free variables, again, will be x2. Let me change color, this one pops more. Well, I dropped that one too, so that's as much as I'll do with that color, I suppose. And then I have x4. All right, so this x2, x3, x4 are going to represent free variables. All right, so normally you would write your system of equations and you would solve x1 and x3. Oh goodness, somebody doesn't know how to count. This is a 4 and the other one is a 5. Let me change that real quick. Much better. All right, so you would write your systems of equations, your solution, and you would write it in terms of x1 and x3, and they would all be written as a function of x2, x4, x5. But that's really time consuming. So this is how you do the null space of the matrix without having to write your system of equations. Well, let's start with span, because a null space is a vector space. So I want to start with that. And so I'm going to grab my vectors. And so how am I going to write them? Well, I have 1, 2, 3 for variables. So I'm going to have 3 vectors that span the null space. Now, how big are the vectors going to be? Well, I have 1, 2, 3, 4, 5 columns. So I'm going to have 5 rows for the null space. So I'm going to start with the first entry. I'm going to turn it into a -2. Okay. So why negative? Well, because whenever you write your equation, you'd have x1 plus 2x2, right? So when you have the plus 2x2, you would subtract it on the other side as -2x2. So that's what this is representing, your -2. Now, let me write that equation just so we visualize it. So I'm going to have x1 plus 2x2. Now, nothing for x3 because of pivot. Now, for x4, I'm going to have 3x4. And then I'm going to have a -2 x5 equals 0. So then I would be moving this to the other side. And then my next equation, because x2 is a free variable, I'd have x2 equals to t. So I'm going to have a -2x2 and I'm going to have which is going to become a negative 2t, and then I'm going to have a t right there. So that second row, x2, is going to give me a 1. So whenever you have a free variable in your, say, fourth column, then the entry in the fourth row is going to be a 1. Now, what do you do with the rest? Well, you have nothing else for x2. So once you put your 1, that closes the row, or the whole vector. Now you just fill up with zeros. So right there, that gives you y3, because I have 1, 2, 3, 4, 5 rows, columns. So I need 1, 2, 3, 4, 5 rows. All right, so I move to the next one, okay? So for the next one, I want to grab this 3 and 1. I'm going to turn them negative, because I would be putting the 3 as a negative on the other side. Subtracting 3x4 on both sides would be technically what I'm doing. So move that one. However, you see here, I already picked a 1 for that row. Whenever you pick a 1 for that row, that to the right, they're all going to have zeros there. Why? Because, well, this means x2 equals t. There's no x4 in this equation. So in the second row, you have nothing. You have zeros after that. So once you put a 1, zeros everywhere else. Okay, so 0. Now, this 1, I'm going to turn into negative 1. Now, my pivot position is in the fourth column. So in the fourth row, 1, 2, 3, 4, I have a 1. That's going to represent the equation x4 equals, let's say, s. And then I fill with zeros below. Next one. So I have a negative 2. I want to turn into positive 2. Now, the positive 4 will turn into negative 4. However, be careful that you already have a 1 in this position, so zeros everywhere. So 0 for the rest of the vectors. Now, negative 1, there's not a pivot. That negative 1, that's why I wanted to avoid them, does not represent the 1 in the pivot. So I'm going to put a negative 4 for that one, 0 for this one, and then I'm going to close it with a 1. And that is going to give me my null space. So you're always going to be doing that, turning into negatives, putting a 1 in the number of row that corresponds to a column, and then you're going to be avoiding anything on the same row. So if you have a 1, make everything 0 after that. And that's how you write them without having to write the entire system of equations. All right, I hope that helps, and I hope that you can actually apply this in your class. Thank you for watching, and I'll see you in the next one.